The question on the board has to do with a problem associated with AC circuits. And the question is, a 2 microfarad capacitor is connected directly across a 150 voltage root mean square voltage 60 Hz AC source. Calculate the following quantities: A, the root mean square value of current, and then the peak value of a current I naught. So we have two parameters to find or to calculate. But we cannot just do that. We need to represent this whole statement in a diagram, and that goes this way. The diagram contains a capacitor offering some amount of reactive capacitance. This is the AC source. You can see the symbol here, and then we close it here. We can put the current, ampere, measuring the current flowing in the system. All right. This is 2 microfarad worth of capacitor, right? And then the source here is 150 root mean square value of voltage, and we have 60 Hz, okay, the frequency. So we have this, and this is very good. This will help us to calculate these parameters, the root mean square value of current and the value of a peak current. Very simple. And what do? The first thing we need to do is to state the formula for calculating the capacitive reactance of the capacitor given. So we do that quickly. That becomes XC is equals to 1 all over 2 pi FC, right? So we already know the frequency is 60 Hz, and then the capacitor value is 2 microfarad. Okay, so we substitute accordingly. We have equal to, that means XC is equal to 1 all over 2. We put everything in parentheses or brackets, so to say, 3.142. This represents the value of pi. Okay, then F is the frequency, and that is 60 Hz. Okay, then we have the value of the capacitor is 2 microfarad. And this 2 microfarad can be stated in this form. That should be 2 times 10 minus 6 raised to the power minus 6. So this is it. So by the time we calculate this together and then find the inverse, the capacitive reactance XC is going to be 1324.4 ohms. So this is the value of the capacitive reactance. The next thing we're going to find, because we have found the value of the capacitive reactance, we are going to use that value to find the value of root mean square current flowing through the circuit via the capacitor. So the root mean square current I, that is question number A. Okay, let me get my duster. Question number A is very simple. Question number A, we're going to find its root mean square value of the current. IRMX is given as VRMX all over the capacitive reactance of the capacitor. Okay, so with this, we will now know what to do. What do? Very simple. We continue with our IRMS is equal to, for this one, this is it. Okay, so it is just equal to 150 all over. This is 1324.4. Okay, so look at it. By the time we simplify, 150 over 1324.4 is going to give us some amount of value. Therefore, we have the value of the root mean square current is 0.113 amps. So we have found the value of the root mean square current. The next thing we are going to look for, we have found the value of this. Take notes. We are now going to find the value of the peak current or peak value current flowing in the system. So what do we do at this point? We need to state the formula. We need to state the formula that will help us to find that. But before I go into finding this value now, let me quickly remind you that it's time for you to subscribe. Give us some thumbs up. Put on the bell button for constant notification. And don't forget to share with your friends, networks, and students. My returning subscribers, my new subscribers, I give you thumbs up as well. Thank you so much. All right? Okay, so let's go back to this. We have succeeded in finding the capacitive reactance as 3424.4, and we have also succeeded in finding the root mean square value of the current as 0.113 amps. Then the next thing we need to do is to find the peak value current flowing into the system or flowing through the system. And it's very simple. What do? We state it because we know that with this root mean, so this is B, we are solving for B now. Root mean square current is equal to I naught all over root 2. So with this formula, look at this. With this formula, we can solve and find the peak value current flowing in the system. Okay? Now we have understood this. What do? We make I naught. Look at this. We make this quantity the subject. By the time we do, we have I naught is equal to root 2, all right, times the value of the root mean square current. Good. Look at it. Very simple. So that is what we're going to do. Just the same way we have found it here. All right. We found this. We have found that. The same way we substitute again. I naught can be found root 2 times the value of root mean square current, which is 0.113. Simple. If we find the value of root 2 and then multiply it with 0.11, we are going to have 0.160 amps. That is the value of the peak value current. That's the value of the peak current flowing in the system. And it's as simple as that. Can you see how we started? First of all, we started by drawing the diagram. From drawing the diagram, we stated a formula that we used to find the capacitive reactance, and that is this. And we made clear substitutions here, and then finally arrived at the value of the capacitive reactance, which is XC. We took it from this point to this point, and then substituted here because we know, having found the value of capacitive reactance, and with this formula we can find the value of the root mean square current flowing in the system. So we stated this, all right? We stated this, okay? This, and then come down here and then substituted for this voltage, root mean square voltage. Look at it. We substituted there. The capacitive reactance is this, and then evaluated, we got this. That's the steps we took. And then we found this. Now the question number 2, we stated the formula. Root mean square current is equal to peak current over root 2. We made peak current I naught the subject at this point, and then substituted accordingly, and finally found or calculated the answer. That is what we have just done. Learning is very simple if you understand the simple concepts. I urge you to continue to subscribe, continue to belong to this community of learners, community of teachers of worth, and make sure you share these concepts, these beautiful, wonderful concepts, clearly explained, deeply explained to your friends, to your networks, to your students, and to every lover of learning. Okay? That is it. See you in my next class, where I will be solving a situation where an inductor is connected in an AC circuit, how to solve it. That's my next class. I'm going to miss you. I'm going to miss you. Come on, come on, come on, come on. Thank you so much.